Okay, on item number 6, we can use the formula for the second law of motion, which is the net forces will be equivalent to the product of the mass and acceleration. So here we are asked to solve for the unbalanced force that is needed to accelerate a 0.5 kilogram block. So that is the mass of the block. And we have two cases of acceleration at 4 meter per second squared and B at 8 meter per second squared. So of course, you will have to do two computations here. So for letter A first, so let's write the formula. Force equals mass times acceleration. The mass of the block is 0.5 kilogram. And then you multiply that with the acceleration, which in case letter A is 4 meter per second squared. So kilogram times meter per second squared is newtons, and 0.5 times 4 is 2. So your net force, if you have this particular acceleration, will be 2 newtons. Let's say it's to the east. And for case letter B, the same process will give you a net force of 4 newtons. And let's also assume that it's directed to the east. So this example is a very good way to illustrate the effect of a net force that you applied on an object. Okay, so we have the same object, but in the first case, you applied a net force of 2 newtons, and in the second case, you applied a net force of 4 newtons. So the mass is the same since we're talking about the same object. What will be the acceleration, the resulting acceleration? So that means, in other words, if you apply more net force on a particular object, it will result to a greater acceleration. In this case, it resulted to an acceleration of 8 meter per second, or a net force of 4 newton resulted to an acceleration of 8 meter per second squared, while if that value is divided into 2 or is half of that, so a net force of 2 newtons will result to an acceleration of only 4 meters per second squared. In item number 7, similar scenario, similar situation, but you are solving for the mass instead this time. So solve the acceleration, the acceleration, but you're given with the net force and the mass instead. If the unbalanced force of 84 Newton is acting on the following masses. So for the first case, it's 4.2 kilogram, and on the second case, it's 8.4 kilogram. So modifying the equation, when you're given with net force and mass, so acceleration will be the quotient of that net force divided by the mass. So for the first case, 84 newtons will be divided with 4.2 kilogram. So newtons divide that by kilogram, your resulting unit will be mass, or will be meter, divided by, or meter per second squared. So 84 divided by 4.2 is 20. Again, let's assume it's to the east. And for the second case, doing the same process, but this time dividing the force 84 newtons by a larger mass, 84 or 8.4 kilogram, what you get is half of the first acceleration, half of 20 or 10 meter per second squared east. Now this is example, or this item is another way of showing the implications of the variables. Ano po? If we have the same net force acting on two objects, but one of the object is lighter and the other is heavier, the acceleration that will be experienced by the objects will be different. So for the lighter object, the acceleration will be higher, but for the heavier object, the acceleration will be lesser. Okay, so in item 8, we are again looking for acceleration, and we are given with a mass of the car, a 1,200 kilogram car, as well as its speed, 50 kilometer per hour, and it is experiencing air resistance. Air resistance is a kind of force equal to 5,000 newtons, and a road friction. So we also have a friction 2,200 newtons if the wheels push with a force of 7,500 newtons. So you're looking for acceleration. Your formula for acceleration is net force divided by mass. Your mass is given, it's 1,200 kilogram. You don't know the net force. So you would think that you would be summing forces, right? But your trouble here is you don't know which forces. We have three Newton forces here in the item number 8, which would be directed to the right and which would be directed to the left. To figure that out, just think of which object, or which force rather, will lead the car to move forward, and which forces will oppose that forward motion. So obviously it is the wheels responsible for pushing the car forward, right? So we will say that 7,500 Newton in the free body diagram would be directed to the right. Friction, of course, is a force that opposes your motion. So that should be on the opposite side. Your 2,200 Newton will be to the left. Air resistance is just another term for friction. So you're actually looking at two types of frictions here on your problem. So it should also be directed to the left. So your air resistance would be a result of air molecules bumping on the moving car. So you have two forces to the left and one force to the right. So if you sum the forces along the x, what we get will be 300 Newton, unbalanced force. So the car is still moving forward, okay, to the east or to the east. And to use our equation for acceleration, net force divided by mass, the division of 300 newtons divided by 1,200 kilograms will be an acceleration of 0.25 meter per second squared to the east. In item 8, you are again solving for acceleration. So a certain force, you have a clue word here, and that means you will be solving for the force. Accelerates a 3.2 kilogram mass by 2.4 meter per second squared. So you're given with mass times acceleration. Multiplying the two will give you the value of that force. Now, we have a follow-up here. What would be the acceleration of a 1.6 kilogram mass when the same force acts on it? So that means you will also be applying that force on another object, which is lesser in mass. So that means that you would expect that the acceleration of the second object will be greater since the mass is lesser, right? So it would be good to first note the given and separate the given for object 1 and object 2. Also take note that the force acting on both objects are the same. So we have a note here that the net force on object 1 is equal to the net force on object 2. For object 1, we're given with mass and acceleration. So we can easily solve for the net force acting on object 1. So since that is the same force acting on object 2, we can then solve for the acceleration using the formula net force divided by mass for the acceleration of object number 2. So solving for the net force for object 1 first, 3.2 kilogram times 2.4 meter per second squared is 7.68 newtons. That is also the net force acting on object 2. And now we can use we can use the acceleration equals net force over mass formula. 7.68 newtons divided by 3.2 kilogram will be equivalent to an acceleration of 4.8 meter per second squared, which is greater than A1, which is only 2.4 meter per second squared. Okay, on item 10. So again, this is a multiple step item. So you would have to do several steps to come up with your final answer. So a 7.2 Newton force accelerates mass 1 by 5 meter per second squared, or meter per second per second. So here, what you should be realizing is you're not given with the mass, but at least you're given with the force and the acceleration. So you can still solve for the mass of object 1. The same force, which is 7.2 Newton, acts on mass 2 and impart to it an acceleration of 20 meter per second squared. So again, you're not given with the mass, but you can easily solve for that. What acceleration will the same force meaning 7.2 newtons, impart to the two masses when they are joined together? So you will be adding mass 1 and mass 2 to get the total mass. And if the same force, the same 7.2 force is imparted on that combined mass, what will be then the acceleration of that combined mass? So again, taking note of the given, separating the given for each of the masses. Okay, starting at mass number 1 first. So net force is given, acceleration is given. The formula for mass will be the net force divided by acceleration. So when you divide Newton divided by meter per second squared, that is will lead you to a unit of kilogram. So 7.2 divided by 5 is 1.44 kilogram. So that's the first mass, 1.44 kilogram. Now, for mass 2, the net force is the same, 7.2. Acceleration is higher, so 20 meter per second squared. So you would say that mass 2 should be lighter, right? So if we divide that, this should be mass 2. Mass 2 is only 0.36 kilogram. So again, if we sum mass 1 and mass 2 and apply the same force, 7.2 Newton, what would be the acceleration? So 1.44 kilogram plus 0.36 kilogram is 1.8 kilogram. 7.2 divided by 1.8 is 4 meter per second. So finally, you were able to arrive with your final answer, which is the acceleration of the combined masses, or mass 3, as we